Hello. Today we're going to be looking at an important part of calculus, which is the derivatives power rule. So let's get started. So if you have an equation, f of x is equal to 5x squared, and you want to find the derivative, these are the steps you should take. So the derivative, which is denoted as f prime of x, is going to be equal to, so the first step is locate the exponent. So in this case, the exponent is clearly 2. Then, multiply the exponent by the coefficient. So in this case, the coefficient is 5. So if you multiply 2 times 5, you have 10x, and then you still have the squared. But you're not done yet. The final step is that you have to minus 1 from the exponent. So your final answer would be 10x. Let's look at another problem. If f of x is equal to x cubed, f prime of x, or the derivative, would be equal to, so take the exponent and multiply by the coefficient, which in this case is just 1. So you have so far 3x cubed, and then don't forget to minus 1 from the exponent. So your final answer would be 3x squared. So now let's look at how the formula for derivative would look like. So if you have the equation f of x is equal to a times x to the power of n, the derivative would be a times n times x to the power of n minus 1. So an easy way to remember this is to swing the exponent and multiply it by the coefficient, and then subtract 1 from the exponent. So whenever you're faced with a derivative problem, just remember the saying swing and subtract, where swing stands for multiplying the exponent by the coefficient, and subtract stands for taking the exponent and minusing 1. Now we're going to be looking at a couple special cases. So let's just say you have f of x is equal to 5x. In this case, this can be rewritten as f of x is equal to 5 times x to the 1, since these two are equal. So using our rule, you swing, do 1 times 5, which leaves you with 5x, but then you have to minus 1. So if you do x to the 1 minus 1, you're left with 5x to the 0th power. Now, to tackle this problem, you have to remember that anything raised to the 0th power is going to be equal to 1. So 5 times x to the 0th power can just be reduced to 5 times 1. So 5 would have to be your answer. Now in this case, f of x is just equal to a constant, 7. Since there are no x's involved at all, the derivative of this would just be 0. So a rule you should remember is that if f of x is equal to any constant, so this could be 7, 2/5, 2/3, just any constant number, its derivative will always be 0. So now let's do some practice problems. You have f of x is equal to 5x to the 4th minus 7x to the 8th. So this time you don't only have 1, but 2 parts to take the derivative of. So to do this problem, first take the derivative of the first part. So you swing, 4 times 5 is 20, and then you subtract, 4 minus 1 is 3. But then to do the second part, since there's a minus sign in between, you just bring the minus sign down and find the derivative of the second part. So 8 times 7 is 56, and then 8 minus 1 is 7. Similarly, if you have two things adding with each other, the derivative is simply the derivative of the first part, which would be 26x, and then you bring the plus sign down, and you find the derivative of the second part, which would just be 3. Let's look at some more practice problems. And for these, since we've kind of gone over all the types of the power rule, feel free to just pause and try these on your own. So, number 1, f of x is equal to 3x cubed minus 7x to the 5th plus 12x. So f prime of x, would be equal to, so first look at the first term, find the derivative of that, which would be 9x squared, remember because you have to do 3 minus 1, then bring the minus sign down. Find the derivative of the second part, 35x to the fourth, bring the plus sign down. Now find the derivative of the last part, 12. So this would be your final answer. Hopefully you've been able to recognize that if you have any number with just an x, let's just say 5x, 12x, 7x, 2/3 x, any constant followed by just one x, its derivative is always going to be just the constant. So the derivative of 5x will be 5, derivative of 12x will be 12, 7x will be 7, 2/3 x will be 2/3, and you get the idea. So looking at number 2, f prime of x is equal to swing and subtract 20x cubed, bring the plus sign down, swing and subtract 26x, bring the plus sign down, and this is just a 7. If you remember, the derivative of a constant is just going to be equal to 0. So this would just be plus 0, so you can just forget about it. So your final derivative would be 20x cubed plus 26x. Now number 3, f prime of x would be equal to, now 2 times 100 is 200, and then 2 minus 1 would just leave you with 200x. Bring the plus sign down. Derivative of 15x, as you remember from what we just mentioned here, would be just 15. Now number 4. For number 4, let's take it a step further and do a challenge problem. Let's find the derivative first. So f prime of x would be, this would be 27. 54 would just become 0. And this would become 48 x to the 5th. So for this problem, let's try finding the second derivative. Don't be alarmed, the second derivative is just simply the derivative of the first derivative. So in this case, let's just pretend f prime of x is f of x, and f double prime is f prime of x. If we were to find the derivative of this, the derivative of 27 would just be 0, and the derivative of this would be 48 times 5 times x to the 4th, since 5 minus 1 is x to the 4th. Now finally, for number 5, f of x is equal to 3 plus 7 plus 5. So you could find the derivative of each section, but you should be able to realize that 3, 7, and 5 are all constants, which just add up to 15. So the derivative of any constant is just going to be 0. So I hope you've enjoyed this lesson, and I'll be making more videos soon about different parts of derivatives like the quotient rule, product rule, so stay tuned. Thank you.